In Chapter 2, Lesson 14, our aim is to identify equations that have no or infinitely many solutions. So first, let's consider this situation. We have two cookie jars here. We have Randy's cookie jar and Frida's cookie jar, and each cookie jar has 5 cookies. We see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the situation that we have here is that the number of cookies that Randy has, 5, is equal to the number of cookies that Frida has. But if Randy eats 3 cookies and Frida eats 2, meaning that our cookie jars will now look something like this. 1, 2, 3 cookies gone, and 1, 2 cookies gone. Well, is the situation still necessarily true? Is the number of cookies that Randy has equal to the number of cookies that Frida has? And we see that the answer is not true. We see that 5 minus 3 is going to, 5 minus 3 is going to be 2, whereas 5 minus 2 is going to be 3. And so these are no longer equal to each other. So we want to keep this in mind as we go through some further examples here, because sometimes we get equations that are not true. So let's look at this situation. 2 nests have the same number of birds. If one nest hatches 5 birds and the other hatches 2, are the nests still equal in size? Let x equal the number of birds in a nest. So let's say that they have the same number, which is x, so x equals x. That's true, because all values of x will equal themselves. If one nest hatches 5, meaning there's 5 more birds than there used to be, and the other nest hatches 2, are the nests still equal in size? Well, if you add 5 to the left and you add 2 to the right, well, there's no way those are equal to each other, and we know that this bird nest is going to have 5 more than it used to, and this one's only going to have 2 more than it used to, so there's no way these are equal to each other. So for this, there is no solution to this. There is no way that that is true. The original one, yes. The second one, no. So a no solution equation is an equation where no value of x is true. And I'd like you to write that down. And let's look at examples here. 2x plus 3 equals 2x plus 7. If we try to solve for x, right, we want to combine. There's nothing to combine. Then we try to consolidate. So let's subtract 2x from both sides. And we get that 2x cancels on both sides. So now we have 3 equals 7, which is not true. And so when we get an equation where we get a false statement, that means we have a no solution equation. Look at the equation on the right. First, we have to combine. So 3 times x, 3x. 3 times 4, 12. So we now have an equation that says 3x plus 12 equals 3x plus 11. And already we can start to see that 3x appears on both sides, but 12 is not equal to 11. So there's no way these could be equal to each other, and we could verify that by saying, well, subtract 3x on both sides, try to consolidate our terms here. We want to subtract 3x, and so that gives us 12 equals 11, which we know is not true. So again, there is no solution. The opposite of this situation is when we have infinitely many solutions, which are equations where all values of x are true. So if we look at this equation at the top left, 2x plus 3 equals 2x plus 3, if we subtract 2x from both sides, try to consolidate, well, now we have 3 equals 3, which is true, but doesn't tell us anything useful. We knew 3 was 3 before we started this. So because any value of x would work here, we're going to say this has infinitely many solutions. Now you might be thinking, well, what does that mean when any value of x will work? Well, let's substitute in some values here. 2, let's say x was equal to 3. 2 times 3 plus 3 is equal to 2 times 3 plus 3. Well, of course that's true. It's the same thing on both sides. So this would be 6 plus 3, so 9 is equal to 9. Sure. We could say that x is equal to 100. 2 times 100 plus 3 is equal to 2 times 100 plus 3. That's also true because something will always equal itself. So an infinitely many solutions equation is an equation where all values of x are true, and we can identify that by obtaining a true statement. 3 is equal to 3. That is true. In the no solution situation, we get a false statement saying 3 is equal to 4 or 7 is equal to 10. Impossible, so those are false. Let's look at this example here. X plus 2x plus 3 plus 3. Well, let's combine. So this is 3x plus 6 is equal to 3x plus 6. Well, that's true, so I don't need to do anything else. It's infinitely many solutions. Infinitely many. All right, let's finish out with this situation. Randy and Frida each have X cookies, and they both eat 4. What value of X makes this a true statement? Well, Randy and Frida had X. They both had it, so X equals X. And then they both eat 4. So X minus 4 equals X minus 4. Well, it started true, and it continues to be true. But it doesn't tell us anything useful because we knew X minus 4 always would equal itself. So this is infinitely many solutions.